Hey, what's up, guys? Mr. Patterson here, checking in with our video for section 23C in ID Math SL. Going to be talking about expectation or expected values for discrete random variables here. We're going to calculate them and we're going to interpret them. All right, so let's take a look at this example. So let's consider the following problem. A die is to be rolled 120 times. On how many occasions would we expect the result to be 6? So when we see the word expect, that means find the mean. Now, if we think about that, it should be fairly common sense because 1 out of every 6 times about 1/6 times it should be a 6. So if I take 1/6 times 20, that's going to give me 120, excuse me, and therefore the mean or the expected value is 20. So to find the expected value for a scenario like this, all we have to do is take n times p, n being the number of trials and p being the probability of success. So if we take a look at this example, it says we can also talk about the expected or mean outcome from one trial of an experiment. Suppose we have 10 counters. One shows a number 1, 4 show the number 2, 3 show 3, and the other 2 show a 4. So down here we see those outcomes and their probabilities with them there. Then it says one counter is to be randomly selected from a hat. Suppose we perform this experiment 10 times. We can summarize the possible results in a table. So it's saying here, because there are 10 trials and 1 out of every 10 is expected to be a 1, then we expect to get 1, 1. If we look at the outcome of a 2, it's going to happen 4 out of every 10 times, so we expect to get that 4 times, 3 times, and then 2 times, etc. All right? So we can look at it from both of those perspectives there. If we are looking for the mean, we can call it the expectation. We can call it the expected value. We can use our Greek letter mu here. We can look at it E of x, the expected value of x. Any way we look at it, it's going to be this formula here, which is the sum of all of the x sub I times p sub I, where I starts at 1 and goes to n. In other words, it's all of the x times p's. So if we look at this example here, it says each time a footballer kicks for a goal, he has a 3/4 chance of being successful. In a particular game, he has 12 kicks for goal. How many goals would you expect him to kick? So if he's going to have 3/4 of them being successful, all we do is n times p, 12 times 3/4, and that gives us 9. In this other example, now we have these different possible values of x, and we're talking about the expectation or the mean of that. All we have to do is 1 times 0.23, 2 times 0.38, etc., etc., etc. We multiply all those out and we get 2.39. So to interpret that, we say in the long run, the average number of magazines purchased per customer is 2.39. Obviously, we can't actually purchase 2.39 magazines, but we still use that value. We don't want to lose any accuracy by rounding it to 2. A fair game. The idea of a fair game is when the expected value is 0. So it's fair because the person playing is not expected to lose money, and the person running the game is not expected to lose money either. Obviously, casinos do not play fair games. They play games that favor the house. Let's take a look at this example here. It says, in a game of chance, a player spins a square spinner labeled 1, 2, 3, 4. The player wins the amount of money shown in the table alongside, depending on which number comes up. All right. So we see here our winnings value. The number that comes up doesn't really matter. All we need to really be concerned about is that the probability of each one of those outcomes is 1/4. So when it says find the expected return, that's how much we're going to get. We're going to do 1 times 1/4 plus 2 times 1/4 plus 5 times 1/4 plus 8 times 1/4. When we do that, we end up getting $4. That's the expected return. I'm going to go back to the questions again. Question B says the expected gain of the player if it costs $5 to play each game. So you expect to get back $4. So if it costs $5, 4 minus 5, you expect to lose $1 for every game played. Let's read question C. Should you recommend playing this game? Duh. No. You're expected to lose $1 per game, so no, you should not play this game. This is not a fair game. All right. Now, that's it for this section here. So we talked about what the mean is and how to find it. and also how to interpret it. For the assignment for this section, I'd like you guys to work on page 616, numbers 1 through 13 odd. Have a great day, guys.